a WEM Dominator Mark 3 amp for service. Customer says a lot of crackling noises, rattling sounds, volume drops in and out, or sometimes goes totally off. Now the WEM Dominator Mark 3 by WEM, made in the 70s, it was really the same amp as several other ones that they made, including Mark 3, the Power Musette Mark 2, the Dominator Bass Mark 1. The 2 EL84, so it's going to give about 15 watts max, if you can get that, and should be 3 CC83s here. As you can see, this one's pretty dirty. There's probably a lot of dirt in the pots for some of the crackling. Transformers don't look burnt out, there's no burning on them, so they should be fine. Now if we look at this component here, this capacitor, it's got a date code on it. Wipe the dust off. Here we are, March 1973, so we know it's made after 1973, and probably not too much longer after that. They're not going to keep these capacitors in for years and years and years. They buy them in batches and use them up. This one's probably got a date code on it somewhere as well, but it's hidden. We can check these out, make sure they're okay. The smoothing capacitors, normally they last okay. Valves, we can check them out. The preamp valves, these are probably Mullards. If they're original, they are. Look, the original Mullard valve, very nice. They don't really wear out. Sockets may get dirty. Now the EL84s, this amp was sent like this without the case, for, wrapped up. This amp's got bent over a bit. It looks like you can see the pins have been pretty mangled over. So they can be straightened out carefully. They're quite soft, you can straighten them. Mullard EL84, probably the original valve. There's no burning on them. I can test them. They're still good, but EL84s do run hot. They do wear out. They're only a small valve. They normally wear out and need replacing. And they should really be matched in this amp as it's push-pull. All this dirt has accumulated over many years. Switches, this bright switch normally goes, the contacts normally goes on it. We try and clean it and it doesn't work anymore. And the lamp normally goes, I don't think it works at all. Just got to connect up the speaker. Check the mains plug. You can see it's an original mains plug, one without the insulating sleeves that they put on them now to prevent you, I don't know if anyone ever did put their fingers in and electrocute themselves, but it reduces that from happening now. I always open the plug and check that the wires are done up properly. Now, as I say, I've got the circuit diagrams originally. It's a fairly straightforward circuit, and I should be able to work out what's happening. It's even from 1973 they were using solid state rectification. They'd done away with the EZ81, so sort of rectifier valve, saves themselves a lot of money, and this of course is very reliable. They went to circuit board construction from their previously point-to-point wiring. Unfortunately, it makes it quite difficult to service. Not that many of these components go wrong. They're pretty good quality components. But if they do, it's a bit difficult to get them out of the circuit board. Normally, possibly cut them out from the top and just try and solder it from the top and take in this board out, which is fixed to all the potentiometers are soldered to the back. If the capacitor has to be replaced, you can use the original wires to connect to if necessary. There's no burning or anything looking unusual. See the resistor there's the other thing that's likely to get hot. They put it on a little space, and there's the bypass capacitor, which normally is fine. I find they don't wear out. They screwed the whole assembly to the wooden base, which is then screwed into the cabinet, and put a couple of rubber grommets. I don't know if that ever made any difference, and a bit of rubber under there for vibration. I'm sure it really didn't make any difference doing that. You can see a bit of wiring underneath. If you need to get this off to do underneath, you just have to take these screws out. Checking the Mullard A84s from the amp, the original valves from the 70s. You set up the Avo Mark III according to the chart, and then the EL84 should draw 48 milliamps, and the gain will be, it says 11.3. So first of all, I put this one on. Set the negative grid volts to, according to the book, and it's doing 43 milliamps, so a bit low. And then we just check the gain like this. Adjust the scale to number 1. It's almost spot on what they said, 11.3, 9, 10, 11 milliamps. It's gone up slightly, about 44. But then the other thing that goes wrong with these is the heater insulation starts to go. So we just check that. That one's good. It's a bit high. It's supposed to be right down at 0. That can cause a problem. I did check the other one. The other one was fine. I've changed the EL84s to a match pair. I managed to sort out in the end. The CC83s look really nice. I haven't done anything else yet except clean the dust off. Just going to ramp up the voltage, just make sure these 2 diodes are normally fine. I just want to turn the voltage up slowly just in case it's got a fault, and then we work on the crackling sounds or whatever connected a load onto the speaker. A little bit of current being drawn. Always check that doesn't go up high, so there's no fault. Voltage is high. As the valves warm up, that'll go down as they start drawing current. That's why you have to be careful when use these solid state rectifiers. When you hit the mains at full, when these are all cold and drawing no current, this capacitor will get a much higher voltage initially than when it starts heating up and the voltage falls down. So you have to make sure that if you change the capacitor, it's got a really good voltage rating. In this amp I would go for at least 450 volts. The light's working, that's good. Anyway, to check the preamps on various things, I often use a probe here. It's this one's got a capacitor built in series with it, just in case you connect it to a high voltage part. And I put it into a high impedance, about 2 megohms, into an amp. I've got an old valve amp there, and then I can listen to the sound at various stages from the beginning through, making sure that each part is sounding right and not distorting or anything. For instance, if you look at the input of here, this channel, we come in, it's amplified by this valve here, no bypass, so they kept the gain down a little bit, and then it goes through this treble and bass circuit here, and then to pin 7 of the second valve. Now that treble point there, I can listen to the sound. There's the treble pot there on this channel, and so I just connect this and well, I can't do it at the moment, just play a bit of guitar. For instance, you play the guitar and adjust the controls. You see with this control it's all cracked in. When you turn it right down, it can cut off, so it's got to be clean. So I can check the sound here and check the treble and bass controls and clean them and make sure the sound's good, and then you work along the circuit here. Here is the volume control here on after the second valve. It's not right on the input, and the bright switch is on that volume control as well, so can connect the probe here, down here, and hear what's going on. As I say, if you connect to a high voltage part, you need I've got a 600 volt 0.1 capacitor in there, which is fine for a high impedance input, which I have on there, a couple of megs. Or this side, if there'd be no voltage, you'd be fine, but it's just to be safe. I work my way along and then I can listen to the sound coming out of the phase splitter, etc., and make sure that everything is sounding good. So at the moment I've got it on there, so to move it to the volume control, we can take it off of there. The volume control's over here. You can get to the actual center pin. Okay, it needs cleaning obviously, but does the bright switch work? Doesn't appear to. Normally the bright switch, which bypasses the vol with high frequencies, I normally find these stop working. Then you can work your way through your circuit, checking all these bits of the circuit, because if you just try and listen to the whole amp all in one go, it's sometimes very hard to work out which part of the circuit's going wrong. So I start at the one end and work my way through. Anyway, this to clean up those pots, and then this is an identical 2-channel left and right, so we can do the other one before we get onto the phase splitter. Plenty of contact cleaner into the pots and that switch. Now that switch is working, and these pots are not cutting out. Checking the sound quality of this point here, right on the power valve grid 10K. I haven't got the power valves in at the moment, so we can check the signal that comes out one side of the phase splitter, then switch to the other one and check what the sound is like on the other one. It should be the same. So the connections are quite straightforward. You've got a connection off the board right there, so there's one there, the white one there, and the white one is just check this side. Check the controls, treble max, bass minimum, volume max, treble down, bass up. Check the other phase size of the phase splitter, and we can check the just show that the other channel's same. So that is the sound that will be amplified. It's quite a nice full growly sort of sound. So the preamp's working real good. I've checked out all the valves now. The 2 Mullard output valves, EL84s, the preamp valves are really good. These are fine. I thought I'd just check over some of the voltages, make sure they're correct. On my original sketch I've got 311 volts, the highest voltage there, drops to about 290, and you've got around about 9 to 10 volts on there. I also measured the resistances of the output transformer. It's way out. If you measure the DC, I had 218 ohms on one winding and only 154 on the other. You'd think they'd be the same, wouldn't you? But they're not. I did measure the inductance and they are about the same. Capacitors are fine, they don't need changing at all. But nothing else needs changing as far as I can see. Anyway, I just turn it on. We've got 250 milliamps quiescent at 235 volts is what we normally have, so turn that on. 235, and that halfway up there is 250. You can look at the voltages. There's 367 at the moment till it heats up and comes down to about 311, just measured there on the capacitor. It's coming down, And there's the voltage on the cathode of the output tubes. Should be around about 9 to 10. Nearly dropped to 311 and it's still warming up. That is actually the AC voltage on one side of the transformer. Don't have to measure that really, but pretty hissy, quite noisy on the hiss and the bass. Bright switch, don't know if it's picking it up, but that's working in good now. These volume controls will still give you a lot of noise if you turn them up when you're not plugged in, because they're after the gain stages. So if you turn this volume up, you're going to get the noise from this circuit coming through, even though you've got nothing plugged in. So you would keep the volume down on the channel you're not using. It's all stabilized now. 9 volts, 312 volts. It's exactly really what it should be. I've got 311 and 9.3, so it's almost spot on. Couple of mods I can do to this WEM Dominator and others that makes it more versatile for modern day playing is to make use of the two channels. Now there's one channel, two channels basically the same, except this one has a bright switch, and normally these days you only have one instrument going into an amp. So if you're using this channel, the other one, all the circuit is just completely unused and a waste. Now I do an input mod where you can have one channel if you plug in there, and if you plug in the other channel, your guitar goes through both, and then you can adjust the tone controls on both of them and add them together. But you do have to move this channel from one side of the phase splitter just through a 470k to this point so they join together, otherwise they cancel out because they're in opposite phases. That's a good mod to do. If you don't want to do this mod, there's one other one you can do. The input of this one and that one if you want, but it makes it too gainy I think. Bypass capacitor on this resistor gives you extra gain and more sensitive. That's what you want for more modern day playing. If you put that on this one as well and switch the bright switch in, it might squeal a bit. So I do it on this one, and then if you've got the input mod as well, you've got high gain on here, and you can mix the two sounds into there. So I think it really updates the amp a bit and makes it more useful. So pretty easy to do. The capacitor, that one there, just goes across the 1K5. It's fairly easy to just solder to the bare ends of the resistor, so you don't have to drill or cut out the circuit board or anything else. Just make sure that they're soldered onto the little bare ends of the resistors. Capacitor there, anything about 10 microfarads, even higher, up to 100 microfarads, no problem. Voltage wise, anything about 16 volts, no problem. If you want to do the other one, you can do it as the 1K5 over here. So let's just check out the sounds. Also modern day, of course, this amp when it was made you weren't really using lots of overdrive, but you can put a overdrive it with the graphic as well. Because the volume control is after this stage, you can really overdrive this stage and maybe get a sound more like you're looking for. So check that out. Just compare the two input channels. Now I put a little bit of boost on there. This side, treble boost, treble boost off, bass, treble on this one. Good wide range of and the volume goes really loud obviously, and that's quite a clean sound. Let's just try it in the other channel. treble. Volume. So, but you can overdrive these even more with a graphic equalizer and without the boost on the input. Really clean sound with boost. More sustain and sort of a more full sound. Yeah. Now with some overdrive. So it really takes overdrive nice onto the input of this amp. Very good sound. To measure the power output of this amp, I've got a graph here I've drawn. Now you've got the watts along the bottom here. So if we were hoping to get 15 watts, now depending on what the speaker load is, well, I've got a 16 ohm at the moment, so we would expect it to be 15 volts RMS. Okay, I've got resistive load up there, can have 4, 8, 12, 16 ohms. I've got 16 at the moment. I've got the RMS on it, 5 volts at the moment. I've got a scope which shows this is the input shape of the on here coming in from the SIG generator, and this is the yellow one is actually connected to the load up there, measuring when it peaks out, starts distorting. So I've got best of all worlds here I can measure. So coming in here I can turn up the amplitude. Now its only frequency at the moment is, we're quite low, 363 Hertz, and you can see it distorts. It's quite symmetrical. That's really supporting there, so we say that's the absolute maximum. You can see it's 14 volts, so we're nearly 15 watts at that frequency. So let's increase the frequency to 4 kilohertz. You see it's distorting quite badly. Turn the volume down a bit. It's about 14. Now here you can check the treble control. Down, up, down, up. And we could do the same on the bass. So depending on where you want to measure the distortion, about there, it's only about 14 volts. It's the best we can get. What about this boost, treble boost? Yeah, you can see it makes a huge difference. Switch the speaker load to 8 ohms to see how well this transformer etc. is matched to the circuit and how much difference it makes. So at 8 ohms we would expect to have a lower voltage to get the same sort of wattage, and I've got it there. Turn it up, you can see it's peaking off, and it's about 9 volts into 8 ohms. It's virtually exactly the same power. So it shows you changing your speaker from 16 ohms to 8 ohms made no difference to the power output of this amp. It's coped quite well, and I could even try it on 4 ohms. Very square at peak. 5 volts only, 5 volts at 4 ohms there. It's not coping with 4 ohms very well at all. It's only about 7 watts, so it doesn't like very low resistance. If you're going to connect various speakers to this, you're going to keep it at 8 minimum. I've cleaned the pots with this Servasol Super 10, and they're quite reasonably quiet now. Yeah, that's pretty good, pretty good. So on this channel with a bit more of a gain, it's still fairly a clean sort of channel. Can add a bit of treble. Bass. And treble. But if we add some gain on the input, try the other channel. Let's add some gain. That's with the bright on. Let's take that off. So I think this channel still sounds better than that one, even though it should be the same, but especially with the extra gain.